Continue miscellaneous exercise based on chapter 9. See question number 8. Question number 8. It is given that the sum of some terms of a GP is 350. The sum of some terms of a GP. Let there are n terms in a GP whose sum is given. Sn is equals to 315. Sum of some terms is 315, which first term and the common ratio are 5 and 2. The first term A is 5 and the common ratio R is 2. Sum to n terms is given. First term is 5, common ratio is 2. Find the last term. We have to calculate the last term and also the total number of terms. So in this question we have given sum to n terms of a GP is 315. The first term is given. First term is 5, common ratio is 2, and we have to calculate the sum n number of terms and the last term. Last term is nth term, an. So we use the formula for sum to n terms. Sn equals to a into r raised to the power n minus 1 upon r minus 1. And the value of Sn is 315. The first term is 5. Common ratio is 2 raised to the power n minus 1 upon r minus 1 means 2 minus 1. So 315 equals to 5 into 2 raised to the power n minus 1 and 2 minus 1 we get 1. Then it becomes 315 divided by 5 equals to 2 raised to the power n minus 1 and we get 6 into 5 30 63. So 63 plus 1 equals to 2 raised to the power n and 2 raised to the power n equals to 64 and 64 is written as 2 raised to the power 6. 2 raised to the power 6 equals to 64. Then we get the value of n equals to 6. The value of n which we get 6. Then we have to calculate the last term means an. So the formula for an equals to a into r raised to the power n minus 1. The first term a is 5, common ratio r is 2, n minus 1 means 6 minus 1. So 5 into 2 raised to the power 5. 2 raised to the power 5 equals to 32. 32 into 5, 162. So the last term, an equals to 160 and the number of terms, n equals to 6. Next, question number 9. Question number 9. The first term of a GP is 1. The first term of a GP, A equals to 1. The sum of the third term and fifth term is 90. Sum of the third term means A3 plus A5 is 90. First equation, the sum of third term and fifth term of a GP is 90. Find the common ratio of GP. We have to calculate our common ratio of the GP. So the third term A3 is calculated by A into R raised to the power 3 minus 1. A3 is calculated by A into R raised to the power 3 minus 1. A5 is calculated by A into R raised to the power 5 minus 1 equals to 90. The value of A, first term is 1. So we get R raised to the power 2 plus R raised to the power 4 equals to 90. R square plus R raised to the power 4 equals to 90. Let R square equals to X. Then this expression becomes X plus R raised to the power 4. It becomes X square equals to 90. Then X square plus X minus 90 equals to 0. Make the factor. So X square plus 10X minus 9X minus 90 equals to 0. From first two terms, we get X common, X plus 10. And the last two terms minus 9 is common, X plus 10 equals to 0. Then X plus 10 into X minus 9 equals to 0. And we get the value of X equals to minus 10, which is not possible. X equals to minus 10. X plus 10 equals to 0, which is minus 10. Not possible. So the value of X comes to be 9. Now put the value of X. We have supposed R square equals to X. So R square equals to, the value of X comes to be 9. And R is equals to plus minus 3. So we get the value of R, common ratio. R equals to plus minus 3. This is the common ratio of a GP. Question number 10. The sum of three numbers of a GP is 56. So let three numbers of a GP be A, AR and AR square. three numbers in a GP, we supposed AR and AR square. Their sum is 56. Means we have given A plus AR square is equals to 56. From these three terms, A is taken common. So we get 1 plus R square equals to 56. First number equation. The sum of three terms is 56. If we subtract 1, 7, 21 from these numbers in that order, we obtain an arithmetic progression. If we subtract 1 from the first term, A minus 1, and 7 from the second term, and 21 from the third term, AR square minus 21. Then these three terms are in AP. It is given in our question that if we subtract 1, 7 and 21 in that order from the terms, then the sequence becomes in AP. This is in AP, and we know that if A, B, C are in AP, then 2 into B equals to A plus C. So since these three terms are in AP, which we have given, so we can write 2B equals to A plus C, means A minus 1 plus AR square minus 21. And we solve this. So 2AR minus 2 into 7, 14 equals to A plus AR square and minus 22. Then A plus AR square minus 2AR is equals to 22 minus 14. This minus 22 will go on left side. It becomes plus 22. And this is minus 14. And 2AR will go on right side. It becomes negative. So we get A plus AR square minus 2AR equals to 8. From these three terms, A is taken common. So 1 plus R square minus 2R equals to 8. And name it second number equation. And we have to calculate the numbers. Three numbers we have to find. Now divide first by second. Divide first by second. So LHS of the first equation is A into 1 plus R square. And LHS of the second equation is A into 1 plus R square minus 2R equals to 56 divided by 8. 1 times A cancel and it gets 8 7 ja 56. Now we do cross multiplication. 7 into 1 7 plus 7R square minus 14R equals to 1 plus R square. 7R square minus R square. minus 14r minus r and plus 7 minus 1 equals to 0. 7r square minus r square minus 14r. This r will go on my left side, becomes negative, and plus 7 and minus 1 equals to 0. So we get 6r square minus 15r and plus 6 equals to 0. And from these three terms, 3 would be taken common. From these three terms, 3 is common. Then we get 2r square minus 5r plus 2 equals to 0. And it comes 2r square minus 5r plus 2 equals to 0. Now make its factor. So 2r square minus 4r minus r plus 2 equals to 0. From first two terms, 2r is taken common. We get r minus 2. And from last two terms, minus 1 is common. R minus 2 equals to 0. Then r minus 2 and 2r minus 1 equals to 0. From here we get the value of r equals to 2, and from here r equals to 1 by 2. So we get the two values of r. R equals to 2 and r equals to 1 by 2. Now we calculate the value of A by putting the value of r in first number equation. So from first, A into 1 plus r, the value of r when we take for r equals to 2. A into 1 plus 2 plus r square means 2 the square 4 equals to 56, and this comes to be 7a equals to 56, and the value of a comes to be 8. 56 divided by 7, we get 8. So when a equals to 8, then the value of r equals to 2. Now from first, for the next value of r, means for r equals to 1 by 2. So put the value of r equals to 1 by 2 in equation number first. It becomes 1 plus 1 by 2 plus 1 by 4 equals to 56. By taking LCM, we get 4 plus 2 plus 1 equals to 56, and 7a equals to 56 into 4, and the value of a comes to be 8 7 ja 56, 32. So when a equals to 32, at a equals to 32, the value of r is 1 by 2. The value of r is 1 by 2. Now we have to find the three numbers a, ar and ar square. So the value of a, we take the first value a equals to 8 and r equals to 2. So we get the value of a equals to 8. Then the second number ar. So 8 into the value of r is 2, means 16. And then the third number ar square. 8 into the value of r, 2 the whole square, 4, means 32. So the three numbers we get 8, 16 and 32. And when we take the value a equals to 32 and r equals to 1 by 2, then the first term a equals to 32, the value of ar equals to 32 into 1 by 2, that is 16, and AR square. So 8 into AR square. The value of A, we are taking 32, and R square 1 by 4. Then that is 8. So three sequences. One, the value of A is 8, the value of AR is 16, and the value of AR square is 32. When we take the value of A equals to 8 and R equals to 2. When we take the value of A equals to 32, R equals to 1 by 2. We get the three terms, 32, 16 and 8. So the three numbers is 8, 16 and 32. Next question number 11. Question number 11. A GP consists of an even number of terms. If the sum of all the terms occupying all the terms is 5 times the sum of terms occupying odd places, then find the common ratio. We have given that a GP consists even number of terms. A GP consists even number of terms. So let S equals to A plus AR plus AR square plus AR cube, and there are even number of terms, means up to 12 terms. Even number of terms means 12 terms. When we put the value of n equals to 1, 2, 3, we get the even number of terms, 2, 4, 6, 8, 10. Then first we find the sum. The first term is A, the common ratio is R, and the total number of terms is N. Total number of terms is 2N. So A into R raised to the power 2N minus 1 upon R minus 1. The number of terms is 2N. That's why we are taking at the place of N. We are taking 2N, even number of terms, 2N. Now it is given that the series formed by occupying the odd places. The series formed by occupying the odd places. Suppose S1 is the series formed by occupying the odd places. Odd places means first place, third place, fifth place. These are the odd places. Means A plus AR square plus AR4. These are the odd places. First, second, third, first, third, fifth place. All odd place. And plus up to n terms. Because there are total 2n terms. 2n terms means some terms and odd terms. So when we take from these terms only odd terms, so the odd terms will be n terms, and we find the its sum. So S1 equals to, the first term is A, the common ratio is R square, and number of terms is n. So A into R raised to the power n, A into common ratio R square raised to the power n minus 1 upon R minus 1. The common ratio is R square. So we get A into R raised to the power 2n minus 1 upon R square minus 1. This is the value of S1. Now from the question it is given that S is equals to, according to question, it is mentioned that S is equals to 5 times of S1. S is equals to 5 times of S1. And the value of S is A into R raised to the power 2n minus 1 upon R minus 1 equals to 5 times the value of S1. The S1 is A into R की power 2n minus 1 upon R square minus 1. A gets cancelled, R raised to the power 2n minus 1 cancelled, and it remains on the left side 1 upon R minus 1 equals to 5 upon. This can be expanded on the formula A square minus B square. So R minus 1 into R plus 1. R minus 1 gets cancelled. And we get R plus 1 equals to 5. And the value of R comes to be 5 minus 1. That is 4. So find the common ratio. So the common ratio R is equals to 4. The value of common ratio R is 4.